Congratulations on hitting the end of this chapter where we were learning about C++ exceptions. We saw that exceptions are a built-in facility we have in C++ to bring problems to the surface and handle them. And it is an alternative way really because there are other features we can use to catch problems in our C++ program, but exceptions are really designed to catch problems and give you cool features you can use to catch problems and handle them appropriately. Again, I am going to remind you that exceptions are a very dividing feature in the C++ community. Some people love them, some people hate them, and it is going to be your decision whether you use them or not in your C++ program. And the big point is that sometimes it's not even going to be your decision whether you use them or not. So it is something you need to be aware of if you are serious on doing things with C++. We started out by looking at our try and catch block. We saw that we could put our problematic code in a try block. And if something goes wrong, we could throw an error. And once you throw an error, code execution is going to freeze in the try block and control is going to go in the catch block where we can catch the problem and handle it appropriately. After that, we're going to see that our code is going to end properly and we could see our end message here. This is something we saw in the chapter. We moved on and trying to understand why we would need exceptions in our C++ programs. We saw that they could help us protect ourselves from things like integer division by zero or downcasting by using references. These are things that would otherwise crash our programs, but the exception mechanism gives us a way out of these problems and we can use this to our advantage. We saw that we could handle exceptions at different levels in our C++ program if we have a chain of function calls. And we saw that the closer you handle the exception to the point where it was thrown, the better, as that reduces chances for your functions not to terminate appropriately. We saw that we could set up multiple handlers at different levels, and you can do this if it makes sense for wherever problem you are trying to solve with C++. We moved on and looked at how we could nest our try blocks, and it is really possible to do that. For example, we have one on the outside here, we have one on the inside, and you can do this if it makes sense in your C++ program. We also saw that it was possible to throw objects of our own classes. So you could set up a class like something is wrong and throw an object of it and catch it in your catch block. And you could use that object to call the what function to figure out what was wrong that caused for the exception to be thrown in the first place. We could do something like this. We could even use objects that are part of an inheritance hierarchy. So this is something we could do. And if we use these kinds of objects, it was of crucial importance to order our catch blocks appropriately. Because if you put the base one first, it is going to catch everything and all the other catch blocks won't have a chance to run. This is something you need to be aware of. But we could solve these problems using polymorphism, and one way we could do that was by making our what member function virtual, and we could do something like this. And with this, we could resolve which kind of exception was thrown at runtime through polymorphism. And this could significantly reduce the number of catch blocks we would need to use in our main function. And this is something we had a chance to look at in the chapter as well. We saw that it is possible to rethrow exceptions using the syntax here. We had a chance to learn that it is possible to set up a custom termination function that would be called if we have unhandled exceptions in our C++ programs. And you can use this to your advantage if you need this kind of thing in your program. We saw that we could set up an ellipsis catch all block that catches all exceptions. And one thing you should remember is that it is advised to put this last. If you put this in front and there are other catch blocks after it, you are even going to get a compiler error, so you should be aware of this. We had a chance to learn about the no except specifier, which specifies that you can't propagate exceptions out of your function. And we learned that the structures of your classes are no except by default, but it is possible to avoid this limitation, but I wouldn't really recommend it in code out there because it is going to make your code vulnerable to a few errors that I wouldn't really want to deal with in my daily job as a C++ developer. We also had a chance to see that there are a bunch of standard exception classes built into your C++ standard library. We had a chance to look at a few examples. For example, we saw an out-of-range exception. We saw a bad cast exception. We could use all these things in our C++ programs. And we had a chance to look at how you could catch them, throw them, and derive from them to really take full advantage of what the C++ exception infrastructure has to offer. This is really all we had a chance to look at in the chapter, and I hope you found it interesting. We are going to stop here in this one. In the next one, we are actually going to do a simple project that bundles together most of the things we had a chance to look at in this course here. So go ahead and finish up here and meet me there.